I'm back. Hope your homework went well and it was easy. This is our last section, and I will be back with you after spring break. This section's a little bit trickier than the last one, so you'll need to pay careful attention. Please make sure you take really good notes and help each other out when you're doing the practice problems. So this is our section 10.3, areas of regular polygons. And so far we've done triangles and quadrilaterals, several different kinds of quadrilaterals. So now we'll get to an any-sided figure, as long as it's regular. So let's go back and talk about what does it mean to be regular. A polygon is regular when, anyone? Do you remember? All sides are equal, they're the same. And all angles are equal. So for instance, a square is a regular polygon. All the sides are equal and all the angles are equal. What's another one? An equilateral triangle would be another one. So those are two that you've worked with so far. We're going to talk right now about a regular hexagon. So do your best to draw a hexagon. They're a little tricky to draw. Make it look as regular as you can. And put a point in the center of the hexagon. All right. Then we're going to draw a circle around the hexagon. Do you remember the name for drawing the circle that's drawn around the hexagon? It is called a circumscribed circle. So do your best. It's going to look probably a little messy. That's okay, but so long as you know that the circle is circumscribed around the hexagon. And then we can draw a line from the center to one of the vertices of the hexagon. And notice that the circle also touches the hexagon there. So what is this kind of line called that starts in the center and goes to the circumference of the circle? Did you say radius? You would be right. Radius. That's a radius. All right, and then there's another special name or another special line. It's drawn from the center perpendicularly to any side. And this one is called the apothem. It sounds like you have a lisp and you're saying opossum. It's the apothem. I'm sure it's Latin. I have no idea what it means. Maybe some of you know. So you've got radius, you've got apothem. All right. Now, if you continue drawing all the radii inside of the hexagon, let's draw them all. You're going to come up with several isosceles triangles. Let's see how many. 1, 2, 3, 4, 5, 6. Oh, is that a coincidence that it matches the number of sides? No. So if we're looking at one of these triangles, let me redraw it a little bit bigger. We'll pull this one out. We'll say that this triangle is the magnification of this one here. And we'll draw in the apothem as well. And I'm going to call it triangle A, B, C. And then we'll put a little D where the apothem touches the side. I want to know how many degrees, or what is the measure of angle A, B, C? Is it an equilateral triangle? I don't know. I know it's isosceles, but I don't know if it's equilateral. So let's go back to our circle. How many degrees are in a circle? If you turn all the way around, you've gone 360 degrees. So I have 360 degrees in my circle. It's been cut into how many slices? 6. So 360 divided by 6 gives us 60 degrees per slice. So this triangle here has a 60-degree angle up at the top. Okay, your apothem comes down. And remember, this is isosceles. So when your apothem comes down, it acts as an altitude in an isosceles triangle. So what does it do to the angle up here? Yep, it cuts it in half. So the measure of angle ABD is 60 in half is 30 degrees. All right, so then let's talk about angle A, the measure of angle A. So this guy right over here. Well, I know this is 30 from before, and this is 90, so that makes this 60 degrees. And you say, wait, Miss Carty, I know this is an equilateral triangle. I already knew that. Yep, you're right. That happens in a hexagon. Hexagons are special that way. So let's try a pentagon. All right, draw yourself a pentagon. Remember, it looks kind of like a house. There's a roof. There's our pentagon. And we need the middle of the pentagon. Remember, it's regular. All right, and we'll draw in all the radii. All the radii. So how many isosceles triangles are there in a pentagon? Yes, 5. So let's take a look at this pentagon. Let's call this angle 1 here. I'm going to draw on the apothem. And this little guy is going to be angle 2. And then this guy down here is going to be angle 3. So let's find the measure of all 3 of them. Angle 1. Remember the circle. There's always the imaginary circle circumscribed around it. So that's 360 degrees divided into 5 triangles. So angle 1 will equal 72 degrees. Oh, no more equilateral triangles in a pentagon. That only happens in the hexagon. So this one's going to be isosceles. All right, angle 2. Remember the apothem comes down and it splits this triangle into 2 equal triangles. So angle 2, 72 divided by 2, or 36 degrees. All right, last one, angle 3. I know this is 36. I know that this is 90. So angle 3, oh, how many degrees inside of a triangle? 180. And we'll subtract off the 72, pardon me, the 36 and the 90. Okay, so angle 3, doing some quick math, 54 degrees. All right, so now I want you to work on something. Do page 548, 1 through 3, and then check your answers with my book. I'll see you in a bit.